All right, here we are asked to construct a frequency distribution table, and actually it's a grouped frequency distribution table because we're going to have intervals for a range of values for each class rather than just counting one single value and how many times it repeats. We've also seen frequency tables like that, but this one is going to be where we are actually partitioning the data into, groups or bins, kind of like you're organizing into little classifications, classes. So what we need to know first is how many classes do we want? And the nice thing about doing it as an exercise rather than in the real world is somebody already decided that we were going to do seven classes. So that's what it says here, using 7 classes. And it also says to use interval notation for the answers. Okay, so we're going to be taking our class limit intervals and turning them into interval notation, which looks like an ordered pair, but it's really from the lower limit to the upper limit. And then also our class boundaries are going to be given in the same way. So what we'll do is we'll construct a table and then we'll come over and put it into the correct format to give our answers. And we're going to do little by little. So depending on whose class you're in and what their copy is like, my copy of this and whoever programmed it did it the way I like it, where I can put in an answer one at a time and check without losing points on the subsequent answer boxes. That way I can just know as I'm working if I'm doing things correctly and correct along the way, and also save myself some time in case I need to make an adjustment somewhere. So I'm not doing double work. All right, so with that said, I also want to point out that our data is given in a format that I don't love. It's workable. We don't have to change how the table is arranged in order to be able to do this question. But if we just take a few moments to change it so that all of our data is in a single column, then it'll be easier when we get to the part where we need to count values that fall into each class. So it's always easier to do that when things are in order. So to do that, to transition, basically take each one of these rows and make it into a column and put all of them into single column, right? That's the goal. I'm going to start by selecting the first row, and then I'm going to copy it and paste it, but I'm going to paste it with a special type of pasting. So if you do your right click on a PC, or I think on a Mac it might be command and click, not sure about that, but you want to get this menu up so that you can choose the transpose option. Now, I just want to make the caveat here, okay, a little disclaimer. Depending on how you are doing your tests, you might be doing it on a lockdown browser, and certain lockdown browsers have their own version of Excel, or rather it's just a spreadsheet app that mimics Excel. And not all of the features are always going to be there. So there are certain things that you might have to do a more you know, manual way, but you can still get it done. So if you were not able to access the transpose paste option, you could simply just take each one of these and relocate them. Okay, and that doesn't take much longer than doing the transpose, honestly. Of course, you can see how little frustrating moments can happen, but I mean, if you take your time and you're careful, it should just take, a few extra seconds to just relocate each of these. So notice that I'm using the white cross cursor to select the values, select the cells. Then I'm getting over to the edge of the selected area to get to the crosshair cursor so that I can grab it and move it. Okay, so I'm just doing that one by one to put them in. But as you can see, this takes longer. Not too bad. I'm just doing Control Z to undo right now to get back to where I was, because now I want to show you again how to do the transpose. So once I copy one of the rows, then I can just transpose paste it. And then do that for all 3 of these, and I'll be done with this part of it. And I really feel so much better once this is all in a single column. Now I don't need this anymore, so I'm going to just delete these. So there's my data, and you can see that I have 30 pieces of data there because it starts in row 1 and goes to row 30. All right, now I'm going to click on the cell and go to the data and sort. Okay, so now that it's sorted A to Z, or from in ascending order, I can see that my minimum value is 1, my maximum value is 48, and I am going to need to know those, but I also want to show you how if you did not have your data fixed like this and you wanted to find your minimum value, you could use the min function and just select the data values, and then same thing for finding the maximum, but it's max, and then select your data value. So it's kind of nice to know that you can do that if for whatever reason you don't want to take the time to reorder the way your data is displayed. I just like to show you little workarounds along the way, but I'm going to go back to the way that I prefer to do this. Oh, that's not what I wanted. Okay, the way that I prefer to do this is to have everything transposed. So I'll go ahead and do that one more time just because it doesn't take me long to do it. I thought I was going to be able to bring it back to where I had it, but I don't know what I did exactly, but we'll just fix this up again. And there we go. Now I'll get rid of these. All right, now, again, I'm going to sort. And even if you can visually find it, you might want to still use the min function. It's up to you, really. So now what we're going to do is we're going to first, oh, I'm missing some information here. Let me get that back. Hold on one second. Let me just put this on pause. I'm missing something. All right, there we go. So we've been told to make 7 classes. Now to do that, we're going to locate the minimum and the maximum values, which is easy to do once they're in order. So the minimum is 1, the maximum here is 48. But if you wanted it to be automated, right, you could, like I showed you before, use the min function on the column, provided you don't have anything else in the column but your data set. If you do have anything else in the column, or you're worried that you might have anything else in the column, you can select the individual arrays, or just the array containing your individual values. And now you've got this in a way that, if you pasted a new data set here, it would update the minimum and the max appropriately. Now we can find the range by taking the maximum minus the minimum. And to find the class width, we're going to divide the range by the number of classes, which is 7. Now, if you have, if the class width that you calculate doing that step turns out to be a number that is not an integer, in other words, it's got digits after the decimal, then you're going to round up to the next integer, okay? But let's say that the range happened to be 49 and it came out to a nice, pretty integer. What you're actually going to do is go up one more. Okay, so that's a little if-then type thing that you might want to write down on your formula card. That's one little thing, is it can be a little different from. Now, one thing that's nice, it's kind of nice, I guess, is you can kind of catch yourself if you mess this up. So if you, let's say it was 49 and you try to use this class width of 7, well, actually your class width would be 8. And so what you'll probably find in that situation is that maybe you're not capturing some of your higher values in the end because you don't have, your class width isn't big enough and it's not providing enough range for each class. Yeah, so something will come up. And again, the nice thing about how these questions are made is I can start putting in my answers to get a feel for if I'm on the right track and make adjustments as needed. Okay, but just remember that you're always rounding up to the next integer. That's the easiest way to say it. The next integer here is going to be 7. Likewise, if my answer if my range was 49 and I came up with this class width, then rounding up to the next integer would be 8, okay? So that's how we would do that, okay? Just remember to round up to the next integer. Okay, so for this one, our class width is going to be 7. And so now we'll start making our table. So I know that I'm going to want to first come up with my class limits because the class limits are going to guide how my boundaries are. I don't know if I said that right. I need my class limits first. Okay, so I'm going to start off with limits, and I'm going to kind of give you a preview here. I'm going to start off with limits in these first two. I'm going to go 1, 2, 3, 4, 5, 6, 7. For these first two columns and my 7 class rows, I'm going to color these in blue. Okay, so these are going to be my limits. Then I'm also going to do boundaries, but the boundaries are outside of, or like the first boundary is right before my first class limit. So these will be the lower boundaries. Okay. Like that. Or you could maybe just write LBs for lower boundaries. And this will be the lower limit. This will be the upper limit. So these are my limits. And then my boundaries, the lower boundaries and the upper boundaries are going to be outside, like right before and right after the limit. So you'll see how that makes sense in a little bit. So once I've got all my limits calculated and I start working on my boundaries, you'll see more clearly what I'm talking about. All right, so there's my table format. Then I'm also going to want the frequencies. So you can put F for frequency or frequency like that or whatever you want to do. Right, so I've got that one last thing there. All right, now let's go ahead and figure out our limits. Now the first lower limit is going to be 1. Now to know what the next lower limit is going to be, I'm going to use my class width. So here, this class width right here, I'm going to be using that. I want to use that a lot. So I'm just going to highlight it, okay? That's going to be an important number for us as we construct the rest of this table. All right, so I'm going to start by taking the first lower limit and I'm going to add the class width, and I'm going to put an absolute reference on that. So just putting the dollar signs in there like this. You can type them in by hand or you can use the function for key to do that. So what this does is it allows me to copy down, and what's happening here is it's easiest to show this when I click on the formula editor bar for each one of these. So for this one right here, notice that it's referring to the cell above and then adding this one. Okay, that's what I want. Now the next one down, it's referring to the cell above, but still adding the contents of the yellow cell. Notice that the yellow cell reference is not relatively shifting, although the lower limit reference is relatively shifting. That's what I want, okay? Now, once I've got all my lower class limits, I can start focusing on my upper class limits. So what I'm going to do is I'm going to find the first upper class limit by taking the lower limit of the second class and subtracting 1. Okay, and now that I have one of my upper limits, I can repeat the process that I just did before, where I'm taking that and adding the class width, and again make that an absolute reference, and then copy it down. And now is a good time to just check to see if we're on the right track. All right, so we're going to come over here. Whoopsie, lost my little, gotta be just so, there we go. So the class interval, in interval notation, I'm going to do parentheses, and then I'm going to put 1, 7, and then close parentheses. And then let's just check it. Nice. Okay, so now I can go through and put each of these down. But I don't know, but that's fine. I'll just go ahead and do it now. Why not? Just make sure it's all good. And so on, okay? Now, after I've entered all those, we can start thinking about the boundaries. Now, the boundaries are going to be halfway between the limits. And there has to, really what this is for, just to give you a sense of why we do this, there's a lot of times we take a frequency distribution table and we use it to create a histogram. So, and other graphs, but histogram is a really good example for why we need boundaries. So if I want to make a histogram to represent this table, I'm going to want to create bars, kind of like a bar graph, but a histogram, you want the bars to touch. You don't want any gaps between the bars. So for my first histogram bar, I'm going to want to start it at the lower limit of 1, right? Let's say I start at 1, and then I have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, I'll make my scale a little different here. Let's say I want to go from 1 to 7, right, with my first bar. And then let's just count, let's find the frequency for this first one to get a sense of what's going on. So between 1 and 7, the lowest value can be 7, the lowest value can be 1, and the highest value in this class can be 7. And I want to count how many there are. I can use the count function for that, or you can just, count them visually. If your data's in order, it's much easier to do that, right? So I'm going to count all these values, 1 through 7. So I have 5 of those, right? So then my first bar, representing the first class of my histogram, is going to go up to 5. So 1, 2, 3, 4, 5. Your frequency is going to be represented on the vertical axis. And so each bar is going to go up to its frequency like that. But then when I go to start the next bar, I have to jump all the way to 8 and then go to 14, right? And so my next bar, and how many are in that next class? Let's see, I'm going to count between 8 and 14. So starting at 10, let's get all these, okay? Press enter. So there's 7, right? So now I'm going to go up to 7 like this. But now this is a bar graph where there's gaps between my bars. What we want is for our bars to be right up against each other. So I want to find the halfway point, which is here would be 7.5, right? So I want instead, also I'm going to go, since I went half a unit to get over to 7.5 here, I'm going to do the same thing. I'm going to widen my histogram in the other direction because you got to be balanced. So now I'm going to have a boundary of 0.5 over here, which is 0.5 less than 1, right? So now I'll have the bar wider like this. And then my next bar will start at 7.5 and go up to 14.5, right? So now I'll have that second bar of my histogram right up against the first bar. Whoa, never saw that before. Just drawing here, folks. Okay, like this. So that's what the histogram is supposed to look like bars just, next to each other. And this is going to help us to see if we have like a bell shape or more of a rectangular shape or a skewed distribution and so on, right? Now, it's not a beautiful picture, but I thought it was important that you get a sense of what boundaries are versus what limits are, right? So we use the limits because a limit, like a lower limit, okay, LL stands for lower class limit. Okay, what is a lower class limit? It's the lowest number in the data set that fits into this class. So I can start with any value, I can start counting with 1 and I can go up to 7 and then I got to move on to the next class, right? So I'm just counting. It's like if I had little trays or like file bins and I was gonna just organize my data into separate little containers, right? Okay, so now that we have an idea of why we want boundaries for our histogram, let's go ahead and figure out what those are. So um, sometimes the boundaries are just obvious and sometimes they're just a little trickier. So the easy way is to say, just like I said before, I know that between 7 and 8 is 7.5. And so basically I can just add to any one of these, I could add 0.5 and that'll keep giving me my next lower boundary. And likewise over here, if I start at 7.5 and keep adding 0.5 to it, I'm going to get, or rather, I guess I would do it like this. I would start with adding, how would I do it? Sorry, I'm overthinking this now. Oh my gosh. I guess I would do it like this, where I would add the 0.5 to the first one and then copy that down like that. Okay, so that's one way of doing it. Another way is like sometimes your data might have more, like these are nice, pretty integer values. Sometimes your data are they're decimal values and your lower limit and your upper limit might have like several decimal places after the decimal. So it can be sometimes a little harder to tell where your boundary should be. And so I also like to give you this bit of information that to find the boundary, the first upper boundary, it's going to be the value between 7 and 8, right? So how I could do that is finding the midpoint. Now, the midpoint formula is to add the two values that you want to find the middle between, you add them and you divide by 2. So you're going to find the halfway point between basically the distance between the two. But um, another way to do this is the average, okay? The midpoint is the average of two values. So we can just do it like this. Find the average of 7 and 8. You see? So that way, if your data is a little more tricky to work with as far as visual identification of what your boundary should be, go ahead and do it this way, just to find the average. Now, once I've got that first upper boundary, it's easy for me. Again, all I have to do is start with that first one I have and add, guess what? I'm going to add my class width. Yeah, and absolute value that, right? So this is how I typically do it. Now you can see, and then just check to make sure. After 7 comes 7.5. After 14 comes 14.5, and so on. Just make sure they're all making sense, okay? For the lower boundaries, I'm going to start with the lowest boundary, or I'm sorry, the lowest limit, and I'm going to subtract 0.5 maybe. If it's easy, like I said, for this, I can tell I just need to subtract 0.5. But if my data was a little bit more difficult, I might instead take, maybe I would take 7.5 and subtract the class width. Okay, see what I did there? Because each of your boundaries are going to be a distance apart of the class width. Okay, your two boundaries are a distance apart of the class width. Your limits, though, it's the lower limits are a distance of the class width, and your upper limits are a distance of class width. So notice if I do the upper bound minus the lower bound. So I'm going to say first, I'll say UB1, UB1 upper boundary for the first class minus lower boundary for the first class. I'm going to get a class width, right? So how does that look? It looks like 7.5 oh gosh, 7.5 minus 0, 0.5, okay? And that gives you what? 7. See that? I just want to kind of point out how helpful this class width is. Keeps coming up, right? For lower limits, your lower limit of the second class minus your lower limit of the first class, what does that look like? That's the 7 minus 1. Sorry, 7. Girl, help me. I messed this up, didn't I? It should be 8 minus the lower limit of the second class, which is 8, minus the lower limit of the first class, which is 1. And what does that give you? Again, it gives you 7, right? So I'm subtracting these two, right? Successive lower limits. Also, the difference between upper limit. So the upper limit of the second class minus the upper limit of the first class. What does that look like? Then I'm taking the upper limit of the second class, which is 14, minus the lower limit of the first class, or sorry, the upper limit of the first class, which is 7. What is that? 7 again. Okay. So while you can subtract both boundaries in the first class to get 7, when it comes to the limits, you have to do successive limits, either two lower limits or two upper limits to get the class width. Right? Notice that the distance between the limits within a class is going to be 6 here, all right? Because you don't want overlap. Anyways, I hope that kind of makes sense here. But at any rate, once you're done with this, once I get the first one, my first lower boundary, to get the next one, again, I'm just going to take it and add the class width. See? Look at that. It's just so nice. Once you get that class width there, and then make sure you absolute value it, make it an not absolute value, but absolute reference is really what I should be saying. All right, there we go. Now, let's just make sure that just like I advised you, to find your first interval for the limits and try it out. Let's find the first interval for the boundaries and try it out before getting all sucked into how to get the rest of them, right? So take some time to make sure your answers make sense. Take a moment to notice that 7.5 minus 0.5 is going to be your class width, 7, okay? And that looks good, so we can continue from there. Now, once you have all your class boundaries entered in and all your class intervals entered in, we can do the frequency. So we're going to start to count. Now, I recommend focusing on the intervals as you're doing this. So you already saw me do it for a couple of these. I'm just going to show you one more time. I'm focusing right now on these two for my third class. My lower limit is 15 and my upper limit is 21. So I'm going to be counting all the values in my data set that start as low as 15 and go as high as 21. So that starts here at the value 16. So we have 1, 2, 3, 4, 5. Nope, we don't want to go any higher than that because then we get out of the class range. So 1, 2, 3, 4 is what I'm seeing there. And again, if I use the count feature, I kind of like this because now I can see what's highlighted and verify that each one of these values falls within the 15 to 21 inclusive, and they do. I can also see that I haven't excluded or forgotten any values either before or after that might have fit in there. And then I can press enter. So that was my third class. You can see that's correct. All right, so continue on in that way. You just keep counting, keep doing however you want to do it. If you want to count them or if you want to use the count feature. Now this time I'm going from 22 to 28. So the first one that fits into that is 25, and then I only have two values there that fit within the 22 to 28 range. And that's my next one. Now, when you get done with this step, you'll know if you did it all right. Obviously, you can do it one by one, which is nice. But even if you did them all at once, like you kept going here, so you got confident, you decided to keep it going here. I'm going to count from 29 to 35 to do these two. Now I'm going from 36 to 42. And then from 43 to 49. All right, now notice that if I add these all up and I haven't done any overlap and I haven't missed any values, my total should be the total number of values that I have. So as you can see, starting in row 1 and ending in row 30, so I have 30 pieces of data, and there I see that all my frequencies are adding up to 30. So that's exactly what I was hoping for. And so now I have all the information I need to create a histogram to help me visualize the data. You can do there are other types of graphs that you can make from this as well. And so we learn about those in another section. And I hope this was helpful to you. See you in the next one.